are, number one, that we pair up individuals so that they're really, really similar. And then after we give them their different treatments, we'll compare their results. Best example of this would be obviously twins. The second option is to test individuals with two different treatments, perhaps a before and after, and then compare the results. This would be also, another example would be like the Coke Pepsi challenge, where I give them the treatments in two different orders. Regardless, both methods will lead to a list, a new list of differences, and that new list is the data that you're going to do the analysis on. All right, here's an example about caffeine dependence. So read the example first. And now that you're finished, note that we are constructing a 90% confidence interval for the mean change. So that means first I need to look at the changes, and then I'll find the average of that change. So I'm going to do a change. Now these two columns, this one is the caffeine column, this one is the placebo column, and I'm going to need to tell the reader what order I did this in, because remember, subtraction, the order makes a difference. So I'm going to do placebo minus caffeine. So now what's happened is that I tested each subject twice, but they were randomly, the order that they got either caffeine or placebo was randomized. So some of them got caffeine first and then some got placebo first. So now I'm going to make a column where I'm doing placebo minus caffeine because I want to look at the change meaning difference. So I'm going to subtract them in this order. I could just as easily have done it in the other order. It makes no difference, but I must tell the reader which one I'm doing. So if I do placebo minus caffeine, these are going to be my numbers. And of course, the easiest way to actually get to those numbers is to put the placebo and caffeine into your calculator. Of course, the order doesn't matter, as a list. And then over here, I would be doing list 2 minus list 1. And that'll give me those numbers, and then I can just record them. So if I'm going to construct a confidence interval, I of course have to check my conditions. And a couple of things are happening in this. I don't notice that they randomly selected people, because these people had to fit a particular description. But what they did do is, at least they used random assignment for the treatments, for the order that the treatments was used in. And of course that would be important because I don't want to confuse, or I don't want confused the results that I get. For example, if I gave you, or if I gave the subjects caffeine to treat their depression on sunny days as opposed to, let's say, dark, gloomy, rainy days, I might not be able to tell if the depression or the lack of depression was due to the sunny weather or if it's due to the caffeine. So that's why the random assignment is important. And the normality, I'm going to have to check by doing some graphing, because you'll notice that I only had 11 participants. So I'm going to look at the graph. As a matter of fact, I'm going to look at 2 graphs for the data that I'm actually doing analysis on, which is this column that I created. So the first thing I did was I checked a box plot, and my box plot looked something like this, not exactly rounded on the ends. So it was fairly symmetric, which is desirable. And the normal probability plot was fairly linear, so again, convinces me of